Hey everyone, in this video, we'll talk about AWS Glue and Apache Hudi. So this is a beginner video, and by that, I don't mean that you are absolutely a beginner. I mean somebody who understands data warehouse and data lake and know the nuances, however, is new to AWS Glue and Apache Hudi. So if you're somebody who has already worked on data warehouse systems, but not sure what is AWS Glue and Apache Hudi, have not heard or used it before, then this video is for you. So in this video, we'll talk about AWS Glue, which is a serverless service provided by AWS, and it simplifies ETL, which is extract, transform, and load. There are few main things which AWS Glue is used for, and that is like for data reading, data transformations, and data writing. There is one more feature of AWS Glue, which is Glue Data Catalog. And this service, trust me, initially you may find it not that important. However, as your AWS services infrastructure or the tech stack continues to grow, you will find that Glue Data Catalog is very important. And the Glue Data Catalog is shared across different services like Lake Formation, Athena, even your AWS EMR running Hive code there or Spark code there. And even you can use it as an external database in your Redshift system. So Glue Data Catalog is actually very powerful. And I believe it is slightly underrated and should get more attention and popularity. Then AWS Glue also provides crawlers, so it helps in automated data discovery. So say you have your source data somewhere, it could be a JDBC connection to a source, or it could be form of different file formats placed somewhere on your S3 or some other location. So with Glue crawlers, you define a path from your Glue to your source, and there is an optional setting where you can also specify what kind of data you are going to read. However, it is very intelligent by default. In most of the cases, it is able to understand what kind of data is coming from the source, be it JSON, Parquet, CSV files, tab separated files. Even you can connect to different databases using JDBC. So crawlers is also very popular and very powerful. I have not used it a lot because mostly whenever I create my data sets, I handle it using Spark code. I don't use crawlers a lot, but in some cases I have used it as well. But good feature to know about, and in your use case probably you may find it useful as well. Then there is a Glue Studio, and Glue Studio basically provides you a visual interface for your ETL job. So you can drag, drop, connect, you can set your source, you can set your target. There are a bunch of transformations already defined for you. So you can select what kind of transformations you want to do while moving data from source to target. So this is all we'll cover in AWS Glue. Then there is Apache Hudi, which is another very popular open source data lake format. I believe if I have to talk today, which is the most popular data lake format, or I shall say, which is the most adopted data lake format, I will say Apache Hudi. There is another format which is Apache Iceberg that is also getting a lot of popularity. I believe Iceberg is also very popular. Hudi is also very popular. Hudi has been there in the system for some time and people use it, and there are enterprises who have already used it to build data lakes, and it's a proven framework. Iceberg is also there. It is trending right now, probably trending more than Apache Hudi, but Hudi has already proved itself. So in this video, we'll talk about Apache Hudi as well. Then why Apache Hudi? Because it is ACID compliant, so it supports transactions and there is versioning. And then it also supports schema evolution. So if tomorrow you are adding few new columns into your table, you don't have to drop and recreate your table or run alter statements. Depending on what kind of source is coming into the Hudi table while loading a Hudi table, it will automatically adjust the schema, and I will show it in the demo as well. After that, I will switch to demo where we build a small data lake on AWS S3 using Apache Hudi, and we'll be running a Spark code on AWS Glue with a data lake format as Hudi. And then all the resources I will use this presentation as well as the code I will use, I will share it with you at the end so that you can also practice. Mind it, these services are not free. Like AWS Glue, there can be some charges. If you're using S3 to store data, scan data, there will be some charges. So be mindful of that while using this demo. So AWS Glue, if you have never used AWS Glue, we'll spend some time to know a little bit more about it so that you are comfortable using AWS Glue. Definitely in this one video, you are not going to become expert. And that was not even the intention of this video, to make you expert in AWS Glue. However, my intention is always to first make you comfortable by doing small demos. And once you are comfortable and you find it interesting and you think that, okay, this is something which can help you in your current project or your future projects, you can do dive deep yourself as well. So that is always my intention, to come up with that level where you find comfort in the service. And if you are comfortable, you can spend more time, explore yourself, or you can ask questions with me also. So if you're following me till now, I will say please subscribe to the channel, like the video, drop some comments. That definitely motivates me. So what is AWS Glue? So AWS Glue, it is a serverless AWS service. So when I say serverless, it means you don't have to worry about the servers or the nodes procurement or maintenance. You just tell AWS that I'm going to run this job in AWS Glue and I want these many nodes. It's a completely serverless service. You don't have to start any server. You just have to mention how many DPUs you want, how many worker nodes you want, what kind of worker nodes, and how many worker nodes you want for this particular job. And now in AWS Glue, there is a feature where you can auto scale up and down the number of workers required for any job. So if you need more, it will automatically scale up. If the job feels that okay, my transformation does not need that many nodes, so it will free some nodes as well. So you can save some money there as well. Then we talked about Spark ETL. So you can implement your ETL pipelines in AWS Spark. And then there is an option to create Python jobs as well. So you don't want to leverage Spark, but you just want to leverage Python and you want to build some application, you can do that as well. Personally, if my requirement is running something purely on Python, I prefer AWS Lambda, which is another serverless service from AWS. I used Python jobs in AWS Glue sometimes when I have to complement my Spark jobs. I generally don't create independent Python jobs in AWS Glue. For that, I use AWS Lambda. But if I have to complement my existing or my new Spark jobs, then sometimes. So I don't want any data frame transformation. I just want to connect to a database and JDBC and get that data into S3. Then probably I can create a Python job. And because in the next step, I will be using that data on S3 to run some Spark transformations on top of it. So yes, but there is an option. If you want, you can create standalone Python jobs as well in AWS Glue. The next set of feature, very good feature, is a data catalog. So it is a centralized metadata repository. It is used for Glue, Athena, Lake Formation, and can also be used by Spark and Hive on EMR and as an external database on Redshift. So what is metadata? So metadata is data about data. Everybody just remembers this definition all the time. But sometimes I've seen when I ask that, okay, data about data is metadata, but can you explain it more? And then I see people struggle. So metadata primarily, you can classify it into two, three uh, categories, right? So you can have operational metadata, you can have technical metadata, you can have a business metadata. So business metadata is okay, this is a customer table, and customer table whole information about customer name, age, cities, zip code, extra. So this information is classification of the data is a business metadata. Similarly, you can classify it on the technical basis also. So technical metadata will be like table name dimension underscore customer, column name customer underscore name, column type is varchar 100, whether it is null, not null constraint. So all these things which physically make up a table can be classified as your technical metadata. And then there is operational metadata also, which you can associate, which is like how many times that table was loaded, when was the last time table was loaded, were there any failures in running the job, is the reconciliation correct, is the financial balancing done. So all these and together make your operational metadata. So all this information about any data available on S3, Athena, Glue, Redshift, EMR, you can use Glue data catalog to store this kind of metadata information. And trust me, it is very powerful. Initially, 5, 6 years back when I started working on AWS Glue, I used to feel that it is not very important. But now I feel, looking at the seamless integration across different AWS services, I feel that it is very important. And then I want to talk about crawlers as well. So you want to discover the underlying data automatically from the source, then crawler is your best bet. So what in crawlers we do is we create a connection to the source. It could be your S3 bucket where the files reside, or it could be a JDBC connection to different databases. And you just specify some conditions, and crawler basically, when you trigger, you can schedule it to run on a predefined frequency, or you can run it on ad hoc basis. And when the crawler runs, it just goes to the source and then it gets the data for you, and it automatically creates a table and registered in the Glue data catalog. So it is actually very powerful, especially when you are dealing with the data for which you don't have much insight what kind of data you can expect from the source. Then crawlers are very good because it is also able to handle different types of input data. So if you are sending it CSV, you are sending it JSON, you are sending Parquet files, you are making a JDBC connection, it will automatically get all the metadata information for you along with the data. So all the column names, column data types, and it will create a table also for you in the Glue catalog so that you can query that table in Athena or use it into your Glue jobs. So it is actually very powerful. Personally, I did not encounter a lot of use cases where I use it on day-to-day basis. I generally create my tables using Spark ETL itself. And because I'm not dealing with the sources where I'm not sure what kind of data I can get. Most of my projects I have worked in the last 5-8 years, the sources were very clearly defined. What kind of data to expect, what volume of data to expect from source was very clearly defined. So I am able to handle it programmatically. I am not dependent on automated data discovery feature of crawlers. Then there is a Glue Studio feature also, where recently a visual interface is provided to the user. So rather than programming and writing all the code, you can use the visual interface, and it will allow you to drag and drop source, target, and there are tons of predefined transformations available for you and mappings available for you, which you can use in Glue to create your job end to end from source to target. I personally don't use it a lot, and the reason being is I feel the visual interface slow down me as a programmer. But somebody, say, who is a business analyst or a financial analyst who does not understands programming very well, but they have a slight idea that, okay, this is my source, this is my target, this kind of mapping or transformation I want, it's a brilliant feature for them. They can use the Visual Studio and create the jobs. But I personally, as a programmer, don't use it a lot. Maybe I just use it to create a boilerplate code by selecting my source, target, and basic transformations. But I prefer to write my code, because I also encountered some situations where programming gives you much more flexibility rather than the visual interface, because some of the options you can code, but on when it comes to visual interface, those options are not available. So but good to know there is a feature available. And to start with, if you are somebody who's starting with AWS Glue, probably this can help you a lot. Right. So this is about AWS Glue. I don't want to overwhelm you. There is a lot of things in AWS Glue, but to start with, as a beginner, somebody who wants to understand what is Glue, I think this is a very good summary of the key things in AWS Glue. There's Glue Data Brew also, but I'll park it for some other time. But for now, this is AWS Glue for you, a serverless service primarily used to build your ETL pipelines. You can create Python jobs as well. You can leverage PySpark in it. It also provides a data catalog feature, which can be used by different AWS services as well. And then there is an automated data discovery via crawlers. And if you are not comfortable, or you're starting out, just if you're just starting out with AWS Glue, there's a Glue Studio to create visual interface ETL pipelines as well. Next, quickly, I want to talk about Apache Hudi as well. So Apache Hudi is one of the very popular data lake format, and this is open source. So you don't have to buy any license or keys to use it. It's an open source data lake platform, which is already very much used by a lot of enterprises. I myself have used it a lot to build data lakes that spans across petabytes of data, and it works pretty well. There will be some limitations which you may feel when moving from a typical database to Apache Hudi, because at the end it is not your database, it's a data lake. So the purpose is different, and that's why how do you manage it or you handle it is also slightly different. Okay, coming back to Hudi. So it's an open source data lake format and primarily used for building data lakes. And data lakes, if you are new, you don't have much inside. Data lake is something, data warehouse. You have a single source of truth. You bring in data from different platforms, transform it, and then you have a single source of truth. You build EW enterprise data warehouse, and then that supports your decision making, and you build reporting and visualization on top of it. When it comes to data lake, you actually have a repository, a centralized repository where you dump all the data, and it can be structured, unstructured, semi-structured. Most of the data warehouse depends on structured and little bit of semi-structured data, but in data lake, input data type is not a big problem. So you can have structured data coming in, unstructured data coming in, or semi-structured data coming in. You just dump the data into a centralized repository. And in many cases, you are not even sure if you're going to use the data right away immediately, or there is a business case at this moment, but still you store all that information for future use cases as well. We primarily use a commodity hardware or a storage which is economical, because you can understand the volume of data you are going to store in it, because you are not limiting yourself to structured data, or you're not limiting yourself to one source. Whatever data your enterprise can get hold of, you're just dumping it into data lake with the expectation that somewhere in future it will be used either to train some machine learning model or for your decision making. But right now, whether there's a use case or not, you're just dumping it. So you want a place where you can store the data securely, reliably, and it should be economical as well. On AWS tech stack, primarily AWS S3 is used to build data lakes, and in this demo I'll be using AWS S3 only. It is ACID transactions. So all the data, if you're coming from a database background, you already know what is ACID: atomicity, consistency, isolation, and durability. So it supports ACID transactions. You can run your insert, update, delete on Hudi tables, and the transaction will either be complete or it will roll back. There won't be cases where it is partially done. Hudi also support versioning. So if you committed a transaction and you feel, okay, my data is corrupt now, I have to revert back, there is an option you can do a rollback also. And the best part which I like is the seamless integration with AWS Glue, Athena, and Redshift. So with AWS Glue 3.0, it comes in the package. You just have to set the configuration and define your data lake format as Hudi, and that's it. So with two configuration changes, AWS Glue works with Apache Hudi seamlessly. And I have used personally a lot. And I can tell you the integration is so seamless that you will not realize that you are dealing with Apache Hudi via AWS. It's like so seamless. Everything will look like a single package to you. Hudi tables are also readable via Athena. And also you can create external tables pointing to Apache Hudi table, include data catalog, and read it in Redshift, which I think is a very big positive, because in Redshift, if you have your data mart and or your preferred analytical engine is Redshift and it is used for reporting and visualization, this is a big plus for you. All right, so this is about the theory. Take a break, pause the video, go back, listen to it again. If you are ready, we'll switch to the demo in the next slide. Let's start with the main demo of this video. So we have two files here. The very first one has 11 records in it, and it is a dimension category basically, where it has information about some sports event and some concerts and some theoretical shows. And in the second file, which is the next day file, I have update for one record. And then there are two records. So source is sending us delta information, the new and updated records. And we have to maintain SCD one dimension table in our data lake using Apache Hudi. So this is our small demo to start with. Both the files are present in S3 location. I generally go with script editor and I write my own script in Spark. There's an option to create Python shell, Ray, which I have not used before, and then Spark. I generally use Spark and sometimes Python shell. But today for this demo, we'll use Visual Editor because it's more easy. So what is our source? Our source is S3. Do we need any transformations? We don't. So I'll just skip it. There are a bunch of transformations already available. So you, as per your requirement, you can use it. And our target will also be Amazon S3 only, right? So if this is done, we'll just click on the source side. Where is my source file? So my source file exists in this path. I don't want to read all the files. I just want to read one. And what is the format? My format is CSV. And what is a delimiter? It's a pipe delimiter. And first line contains column header, which is true. And I will infer schema. What is my role? This role has, this is the AWS Glue service role, and it has access to S3 bucket as well, where the data resides. So you can see the schema it has already detected. And then you can preview the data also. It takes time sometimes. We'll go to the target. Now in my target, what format I want? I mentioned earlier that there are three data lake format available: Apache Hudi, Delta Lake, and Iceberg. For this demo, we are creating Apache Hudi table. What will be the name of the table? We'll say dimension category. There are two table types: copy on write and merge on read. In this case, we'll create copy on write only. What is the operation we are trying to do? Are we trying to do insert only? Maybe this is the first one. I could have chose insert or bulk insert, but I don't want to change my Hudi write operation with every run. So I'll keep it as upsert. So update and insert. For upsert operation, you need what is a record key field, which is a primary key in database terminology. So my category ID is my primary key. If there are two primary keys records, then which one to pick? So I will choose date, whichever is the latest one, pick that one. Compression type, gzip, snappy, whatever you want, you can choose. Where my Hudi data will be stored. So I will choose Hudi output, this bucket. So my output of Hudi will be stored in this S3 path. I want to create a table in the data catalog and update with new partitions, everything. So what I will use db Hudi, my and runtime parameter. If you want to choose anything, enter a table name for the AWS Glue data catalog. I will use dimension category, right? And this is my database name. This looks good to me. I think if you want, you can use partition. Category group is my partition. So I think my configurations are done. I'm good. I will just go to the job details. I will give it a name 001 Hudi Glue and description. This is the role. What type? It is Spark type. Glue version, I'll keep it at 4.0. What language do you want? Scala or Python 3? I will choose Python 3. And I will keep the worker to G1X only. Do you want to scale up or down? I am not right now. I'll just use 2 as my requested number of workers. It will analyze your job, will tell you how to. I don't want to use flex executions. Number of return is 0. I will keep timeout to 10 minutes. So if something configuration is missing or the job just keeps on running, I want it to time out after 10 minutes. There are advanced properties, right? And do you need any catalog here? Use Glue data catalog as Hive meta store. any additional Python libraries or job parameter. Since I'm using Visual Editor, I don't have to specify. Else, if I would have been writing my own script, I should have specified at least 2 parameters, and we'll talk about that. And this is the script that is generated. So I'll just save it for now, see if all the configurations are right, and I will trigger this job now. So the job is running, and there will be continuous log. So it will take few minutes for the job to run. In the meantime, what I want to do is I want to talk about input arguments. And I mentioned that there are 2 configurations which we have to take care of. The first is obviously the data lake format, which is Hudi. So if you are supplying your own script, you have to make sure that data lake format equal to Hudi is definitely set as a parameter. And the other necessary input argument is configuration, and you have to set Spark serializer and Spark SQL Hive. So these 2 properties you must set if you are using Hudi on Glue, which is data lake format, and this 2 values as configurations. There can be more value in the configurations as well, but this is the minimum requirement: configurations and data lake format. If you're not setting it correctly, then your job will fail and you will not be able to run Hudi jobs properly, right? Let's go to the script tab in the meantime to see what exactly it has generated. So it is trying to create a dynamic frame using the input option what we have given. So it will read this file from this path and will create a dynamic frame. Then in the next step, it is setting up the Hudi options. So copy on write table, what is the Hudi table name? So it is not very readable. What I will do is I'll make it readable and will post a screenshot on the video so that you can read all the options. What kind of write operation you are doing, what is your record key, which is basically what is your primary key, what is a pre-combined field. Pre-combined field is if there is more than one row for a primary key, which one to pick. So in our case, whichever is the latest one, pick that one. Partition, what is your partition column? So category group is my partition column. Do you want Hive style partitioning or not? So once the data is generated, I will show you what is Hive style partitioning. There are 2 type of partitioning you can do, and this basically impacts how the data is physically stored in your physical storage, S3 in this case. So the style will be different. In Hive style partitioning, you will have column name equal to value like that. In other, it will be simply the column value / column value like that, and we'll see more once the data is created. The compression is gzip. There was option for LZO and Snappy as well. Hive sync enabled true. Hive sync database DB Hudi is what my database name is. This is my table name, dimension category, and category group as my partition, and extractor class. Okay. So yes, so these are the properties it has set. And in the next step, it just convert the dynamic frame to data frame, and then it use a data frame to write. And with all these properties, add in this path S3 AWS Glue Hudi, right? So this is all about the script, what it has generated. Let's see, my job is complete. It took around 1 minute 53 seconds. Now what I will do is I will go to my data catalog, databases, and we gave DB Hudi as my database name. So there is a table already created, right? Now I want to see the output, like how my data looks like in this table. So you can see Hudi has added 5 technical columns, which Hudi uses internally to process the data. I want to view my data. So I'll just click here. I'll go to, and it will take me to Amazon Athena. And in Amazon Athena, I'll just remove this limit 10 because my file has 11 records in it. So I will just run the query, and you can see all the 11 records are present in the table. These are Hudi commit and other technical columns maintained by Hudi, but these are my business columns, right? And all the business columns are present. 11 records are present. Bravo! You just now created your very first Hudi table in AWS using Glue. My next step is I want to show you how we can run update and insert in Hudi. So what I will do is I'll come here, and enough of visual ETL is what I will say. I will click on edit script, and as soon as I will click on edit script, what will happen? The visual tab will go away. So it is giving me a prompt, and I'm fine with this, because one thing I don't like about visual editor is you see here the names. These names does not make any sense, right? These are not proper business names. So if you follow proper naming convention in your project while coding, these names will be flagged, right? What is this Amazon S3 node and then big number, right? So maybe you can put S3 source input, category input, something like that, some meaningful name, right? Which I don't like. That's why I prefer to write my own code. But yeah, visual editor is good. It generates a boilerplate code. It saves a lot of time. Now what I will do is I'll simply switch to my day 2 file. And now I will read day 2 file. Everything will remain same. I will just save the job, and I will trigger the job again. So my idea is that now when this data is already loaded, now when day 2 will run, it will get 3 files. So source, assuming that source is sending us delta. So on second, this row number 5 has changed. So if I see here, 5 was MLS, Major League Soccer, and the name is changed to MLF, Major League Football. And then there are two more entries added, Indian Premier League and English Premier League. So my expectation is my Hudi job, which was 11 records, it will convert into 13 records. And in 13 records, what I will see here is the fifth record will also change from Major League Soccer, it will become Major League Football. So this is the change I'm expecting. And if this is done, I'm able to maintain a SCD one dimension table in Hudi. So I am creating a data lake using S3 as my storage, Glue as my processing engine. In that, I'm using Apache Hudi. So you see all the connection, how everything is coming together to build a data lake. I'm able to replicate SCD1 and Hudi support asset transactions. You can run, insert, update, deletes, everything. I will click on continuous log. So if you are using AWS Glue, you can use this continuous log tabs and it shows you what exactly it is doing, what is happening in the backend. So, and it is very insightful. These are basically the driver logs. You don't have to go anywhere. It saves a lot of time. Here itself, you can see what is happening. So you see here, it is doing everything. Schema completed, no schema differences. You see all this, such a good information I'm getting. I'm just looking into my driver logs and it builds more insight to what is happening at the backend, how exactly it is processing, it is doing the reconciliation, it is doing post processing, it is checking the schema, whether any schema evolution happened or not, what is the input data, what are my, so you see here add files, so number of files. And I mentioned earlier that I will show you how the data looks like, right, on S3 also for the Hudi table. So we will have a look at that also. So this is my Hudi output. So you see here how my Hudi output looks like. So here it is storing my data. And this is Hive style partitioning, where it will use the column name with the value. So category group, which is my partition column, and what is the value? Shows, concert, sports. So we click here, you see here Hudi partition metadata, and this is internally the file is stored in a Parquet format, and this is Hive style partitioning. If I would not have used Hive style partitioning, you could have just seen concert, shows, sports. There is no category group equal to sports, right? So this is Hive style partitioning, and then there is another style partitioning. So let's see if our job is already complete or not. So yeah, our job is complete. I will go to Athena. I will run the same query again. And this time I'm expecting 13 and I got 13 records. So 12 and 13, two new records are added, where you can see the date also here. I will just sort it on the basis of date. So you see here, and row number 5 is also updated from Major League Soccer. It is updated to Major League Football. So you see here, I'm able to maintain an SCD1 table using Apache Hudi by running AWS Glue job. And that's how it works. This is the script. If you want, you can now change the names to more meaningful name before deploying it in the production. We talked about job details also. We check some of the continuous logs also, and input argument. Always remember the configuration of and data lake format. These two input parameters are must to build a Hudi table using AWS Glue. So that's it for this demo. One more thing, if you want, if you have a Redshift, you can export this database as an external database in Redshift, and then you can also query this dimension category table directly in Redshift as well. So that is also possible. All right, that's it for this demo. Hope you learned something new from this. If you have any questions, feel free to leave a comment and I'll try to answer it. Thank you so much.